two blocks of equal mass m are tied to each other through a light string. Tied to each other through a light string. One of the block is pulled along line joining them. One of the block is pulled along the line joining them. So suppose it is pulled along the line joining them with a constant force F. Find the tension in the string joining the blocks. So this is the situation. Okay, so what are the, okay, suppose we call it A, we call it B. Both have same masses M and M. So what are the different forces acting? So first we will see on B. What are the forces? Mg, normal NB, F, and here there will be tension. So for B, this is the forces. For A, Mg downward, normal upward, and only tension rightward. So these are only three forces. And there is no friction, nothing is written here actually. Actually, it is not writing that it is kept on a surface. I have kept it on a surface. Actually, this experiment is in space. You have not to even consider the gravity, because nothing it is written, it is kept on a surface or whatever. So just two objects and pulling with a force. So if I write different equations, so if I write for A, equation along vertical. So vertical means what? Suppose we consider this as X and this as Y. So equation along Y. If you consider equation along Y, so along Y, object is not moving. So NA here, NA will be equal to Mg. So this is along Y. So NA equal to Mg, balanced. Now we write equation along X. Along X, object may move because of the force applied, the tension applied. So we have only one force, the tension, that will be equal to MA. MAA. We will write like this. So this we can write for object A. Now one thing also is clear here. Since these two objects are tied with a string, if acceleration of B is A, then acceleration of A will also be A. So both the objects has common acceleration. Both the objects have common acceleration. So what we can do is we can write it like this: T equal to MA. Similarly, we will use for B. For object B. For object B, if you see along Y, the forces are what? NB upward and Mg downward. So that is 0. So NB is equal to Mg. This is along Y. Now along X, if we see along X, there is a force F and there is a tension backward. There is a tension in backward direction and only these two forces. So this two will be equal to M into AB, and AB is same as A. So we can write like this: so F minus T equal to MA, and here we have T equal to MA. Now if you use, suppose this is equation 1 and this is equation 2. If you solve these two equations, you can replace the value of T. So from equation 1, we can replace value of T. So T is MA, so that is MA. So F we are getting as how much? 2MA. So A is how much? F is getting as 2MA. So how much is A? A is F by 2M. So this is the acceleration. A is F by 2M. Now what will be tension? So tension is MA. So M, and at place of A we will put this value. So that is F by 2M. So how much we are getting? We are getting F by 2. So the tension which we are getting between the two objects is F by 2.